Hello, good morning. This is Nas from NV Network Lessons. Happy New Year to everyone. Hope you have a healthy, wealthy, and a prosperous Happy New Year. Having said that, we're going to dive into today's lesson. Today's lesson is a physics equilibrium problem. You can almost certain that you will have you will see this problem on your exam. So without any further ado, let's go ahead and get started. Let's say I've taken the liberty of drawing the diagram on the board in interest of time. So basically, just look at this. This is a ramp right here. This ramp has a certain angle, which is theta. Then you've got two bodies. One body has mass m, the other body has mass 2m. So twice the mass of this. And then we have a fixed on the ramp right here. And then we've got a rope which is pulling this M. And then there is another rope which is pulling this mass body with 2M. What we are asked is to find the tension T1 and tension T2 in terms of mass and theta. Okay, so that is what we're going to do. So now, in order to solve this problem further, what we have to do is we have to draw a free fall diagram, free fall body diagram. In other words, what you do is that you are basically going to zoom into just 2m, find the components, find the tension just by focusing on 2m. That is what I mean when I say free fall body diagram. And then later on, we're just going to focus into M, draw a free fall body diagram. Okay. So now imagine in your mind, that this slope right here, this ramp right here, you draw an x-axis and y-axis in your mind. So if this right here, my friends, is the ramp, right? You're going to say this right here is my y component, and this right here is my x component. All right, so obviously this right here is going to be negative y, and this right here is going to be negative x. You're just imagining this in your mind. You're tilting your head like this and saying, okay, I'm going to draw x, y, and x with respect to this slanting ramp. Okay, so now I've taken the liberty of drawing the free body diagram of block 2, the one with 2 mass, which is 2m. Okay, so basically we are just focusing, zooming into the block number 2. Okay, so now let me ask you this. What I can do is I can basically say, obviously there is a weight component. You have this body on the ramp which has a weight which is basically going vertically down. Okay, that is the force which is pulling the block downwards. Now what is that force which is pulling the block downwards? It's gravity, it's the weight, right? And what is weight? Weight is equal to mass into gravity, but in this particular case the mass is 2m. So then I can write force is equal to weight is equal to 2mg, correct? Now, what we do is that I just want to point out before I dive further into this. When I draw a perpendicular, okay, perpendicular to this slanting, then this is going to be my y component right here, and this is going to be my x component right here, which is parallel to this ramp. Okay, and what I wanted to mention, that when you do this angle theta is always going to be this angle theta. This has been proven in geometry. I don't have time to prove this in geometry, but trust me, it is basically based on the similar angles and so forth. If you're interested, I will probably do a lesson in geometry to prove that, but for right now, just trust me. This angle right here is equal to this angle. So now in equilibrium, okay, remember always that sum of forces in x direction is equal to 0. All right, we agree on that? Now what we do is that we basically find out what are the components, the x component. So the x component, my friends, is going to be always equal to 2mg sine theta. All right, you agree on that? And then the y component, sorry, yeah, this component right here is going to be mg, let me write this down, mg cosine theta. Okay, so that is basically, sine theta is perpendicular over hypotenuse, cosine theta is base over hypotenuse. So that's exactly what I did. This is the perpendicular, basically, and this is right here. You have the y-axis, and as you know, sine theta is equal to perpendicular over hypotenuse. Okay, so we are basically finding this right here. If you think about it, you draw this line, and this right here is the perpendicular, and this is 90 degrees. Okay, hope that's clear. So now what we do is that we have this. Now what we do is that we actually go ahead and plug in the values. So we know f function of or summation of forces in x direction is 0. So in this particular case, we see that this right here, T2, is basically pulling the mass away. Okay, so then I can write minus T2, okay, plus what is the force which is pulling in the x direction? This right here, 2mg sine theta. All of this is equal to 0. Okay, so then what we do is that we just basically rearrange algebra, and we say T2 is equal to 2mg sine theta. So my friends, you have successfully found out tension number 2 in terms of theta and mass. Now let's go ahead and see if we can draw a free fall body diagram for block number 1. Okay, so I'm going to go ahead and erase that so that I need some more space. So let me go ahead and draw the similar diagram right here. So you have this ramp, okay, and this angle, which is theta, is the same. Okay, and I'm just going to draw M. I'm going to draw it a little bit smaller because it's M and the other one was 2M. Okay, now in this case, what we have is we have this fixed ramp right here, and then we've got the rope tied. Okay, and it's pulling. This is T1 right here, and then this is T2 right here. Okay, so now we do basically the same thing. What we do is that we know the weight is acting vertically down, and in this case, force is equal to weight is equal to just mg, because in this case mass is just m. Now we draw a perpendicular based on this ramp right here. We draw a perpendicular, and this angle right here is 90 degrees. Okay, so now F force, summation of force in x is equal to 0. Now let's go ahead and analyze this. So in this case, this is going to be right here mg sine theta. If you recall, it was 2mg sine theta because the mass was 2m in case of block 2. And then this right here, my friends, is going to be, as you can already guess, mg cosine theta. Okay. So now let's go ahead. Now life is easy. Now life is easy. So what we do is that the force which is acting this way, obviously that's going to be minus T1. As you know, its force is going this way, plus T2, this force going this way, plus mg sine theta, force which is acting along, the component of the force which is acting along x-axis. All right. Now if you do the algebra, rearrange this right here, you basically get, but before I do, just look right here. We already found T2. So what we do is that we plug in the value of T2 in here. So minus T1 plus 2 mg sine theta plus mg sine theta. Okay, so if you do rearrange this, so T1, tension 1 is equal to 3 mg sine theta. So we have found successfully tension 1 in terms of m and theta. G is just a constant, it's 9.8 meter per second square. And then we found T2 also. All right. Now, one thing you've noticed is that T2 tension is less than the T1 tension. Why is that? Because T1 basically is, if you look in here, it has weight of m and 2m block. So it makes sense that T1 is more than T2. Thank you so much for watching. You all have a wonderful day and a happy new year. If you like the contents, I would request you to please share and go ahead and give me a like. Thank you.